Co? Ale wejdź na YouTube'a. A wejdź, zobacz tam.
Rzeczywiście nie widać kontentu. Ja bym ustawił po prostu kamerę. Jeszcze troszkę? Listę na chodzenie.
To działa? Co widać coś? Co to nie działa? Czekaj. Może dołączę na zwykłe USB. To się nie świeci nawet. A, dobra. No i co? O, działa. A w drugą stronę? Tylko w jedną jest.
I tutaj jest.
O, dobra.
Czasem chyba trzeba 2 razy.
Aha, bo to przestawia ten, dobra. To przestawia to. Jak to kliknę, to co? A, dobra, tak. Jest? O, jest. A to i tak, w sumie nie będzie tego widać na YouTubie, ale tu będzie widać. O. Dobra.
Jeszcze możesz sobie ten ekranik z...
Tak, no, z tym notatkami, nie? Czekaj, to sobie muszę... W tę stronę. Co, widać tam coś, czy nie?
No, popatrz.
A to widać, tak? Wszystko. Działa. Halo, halo, słychać mnie?
Tutaj.
Będę krzyczał. Ja głośny jestem. Ogarnę.
Tak?
No.
Alright, so just
Yeah. We can start.
and let's welcome the partner Mariusz for explore a bit the combination of robotic process automation with agents and human in the loop. So let's welcome him with a round of applause.
Okay, so hello everyone, greetings to be here. I'm delighted to be here. So today we'll talk a little bit about the future of robot processing automation and hybrid RPA with AI agents and human in the loop. So for over 4 years, I've been working in robotic process automation with 2 platforms, UiPath and Blue Prism. Actually, I'm working with Blue Prism. Today I will share my expertise of how, from my perspective, will look the future of robotic process automation. So yeah, let's deep dive into this topic. We have 45 minutes, maybe 2 hours. So we have plenty of time today. So yeah, if you have any questions, there will be a space for this at the end of this presentation. There will be Q&A section. So yeah, let's go. Okay, so let's start from foundation. Does anyone know what is this technology, robot processing automation? Does anyone are familiar with this technology? Okay, nice. We have some person. So yeah, what is RPA? We start from this one, from this topic. So what is robotic process automation? Robotic process automation is a software application, let's say, technology, which enable us to work as a human using not this robot, but some of users might think, oh, is this robot need a desk or something? No, it doesn't. So let's go deep dive into what is RPA exactly. So we have digital workers. Our digital workers are like human workers. So in the company systems has own username or own passwords to the Microsoft 365, to the any tool which is required for the robot. So we can call it digital worker. And this digital worker is based, RPA at all is based on a software technology that interacts with web tools, not web tools, and we can say that our technology is a bridge between a backend solution, because sometimes we need to wait more for a backend solution. So there is a place for RPA where we can easily be this gap for the time when this backend solution will be delivered, because we can do it faster. And we can easily scale our processes. Sometimes RPA, like I said, is temporary solution, but sometimes we think it will be a temporary solution, and at the end of the road, it's not, and it's become permanent solution. So yeah, that's all about digital workers. So we can easily adapt to any environment. We can easily attach any of application, whether it's a web tool, application itself, any CRM. So we can see that can be any of 365 tool from Microsoft, Outlook, Excel, Word, whatever. We can use also API to be faster. Of course, it depends whether we have time and accesses and endpoint to do this. But if yes, and if we have enough time, we can do this, and we can have faster solution. Next, we can connect to the, for example, Salesforce, like I said before, to the any CRM. For example, SAP. And much more, to be honest, we can do anything and anywhere. So it's up to our organization whether there is an access for the robot to any tool or system. Okay. So yeah, this is Blue Prism. We are working actually on the Blue Prism. So this is the main page of the business process in Blue Prism. Inside each page, such as startup, load queue process, we have different blocks, and there is actual process logic structure in that blocks. Blocks like, for example, this one, and so on. So one of the most powerful elements in RPA is the work queue. So as you can see, this is the load queue. This is a page with load queue logic inside. So this page contains logic for adding each item individually. If we are thinking about item, we think about, for example, email, for example, any case in SAP or whatever. It can be anything. This allows a single business process inside this page to run 1,000, 10,000, millions even cases per one run. So we have this full logic inside these pages. which enabled us to run a robot, and the robot has a queue, because this load queue is creating a queue, so email by email or something else, and then this page with process, with business logic, can do this process. After all, it will be a success or not. If it's not a success, that will be a marker's exception. And at the end of each business process, it can, for example, send a report if process will have a report logic, and then we know how many exceptions do we have and how many successes. Okay. So to be honest, the real power of RPA is scale. So as I mentioned before, we can do dozens of thousands items per run. And of course, the most important is the load queue as well. So let's go further. So that is a simple sample of simple, let's say, logic, business logic inside a page. So inside the page, as you can see, we can have start, end. We can have only one start, multiple of ends. We can have these blocks, and in these blocks we have action. We can give their input, and there can be any output. But I will go further in the next slide how it works. Here we can have validation, whether after open subscreen whether this data is correct or not. Here we have Boolean, whether it's true or not. So if it's true, robot will press a button in SAP. And if it's not, if it's it here is false, then robot will end and do nothing. And what about these blocks? Inside these blocks, as I mentioned, are actions. And here is a magic, because we have business objects, and in business object we have action. So each business object can have multiple of actions. So this is a sample of one of this action in business object. And the rules and the idea is that this business object doesn't contain business logic. Why? Because then when we create one time this action, we can use it, copy paste to another process. How it will recognize whether it will be this logic or not in the process, because in the input parameter we can give technical ID of button. So for example, press button can be for any button, and so on. And of course, inside this block sample, we can have a code, which is our action itself. So it can be C#, VB, or any other language, programming language. So yeah, that's how it looks like. So we can go to the next slide. And here is another magic in RPA, not only in Blue Prism, of course, but in Blue Prism it looks like this. It is application modeler. Application modeler allows our application to use user interface to identify an element and work as a human. So when we are not working in our business process with API or any backend solution, then we can use user interface to create this solution faster. So then there we can see a lot of attributes. Here in the example, we have Google Chrome and toolbar search in Google Chrome. So basically, first we click identify. I will show you on the next slide. Then we have these attributes. We don't have to use all of these attributes, because as you can see, there is plenty of these attributes. Then when we identify the element, then we can choose which attributes are the most important for us. And if we are not sure whether we were right or not, we just can highlight these attributes and check whether this identifier works enough. So how it looks on the other screen, it looks like this, that here we are using the browser mode to identify this element in the violet rectangle. So here, when we just click Control and left mouse click, we will identify this element. It can be any element on that site, to be honest, or any application, whatever. And then we can just use it in our robot as an element in application modeler. We can create an action for this and go with the flow. So we have a small break for water. What's next? Okay, so let's go further. We know what is RPA for now. So where is RPA? So where is RPA? Small and large enterprises. To be honest, it can be value for any company, for any enterprise, because it can be a small business process, it can be large, complex business process. It depends of our needs. So to be honest, for now, industries such as logistics, like our company, banking, insurance, healthcare, that's the main industries where RPA is using for now. And yeah, and what next? One of the most important rule is that should be repetitive rule-based tasks. So let's say that our process is doing monkey job and repetitive tasks. So if it's really a simple process, but there is plenty of these items, then why not? We can create a business project for that. And the most important in the beginning is the assessment, because we need to know whether this process will be worth it. Because we need to know before we will develop this from the business perspective, how many items will we have, how many emails. So here we have analytics department, and our analytics just discover with business side, with business departments, is there an opportunity to do this or not, creating a document which is describing step-by-step business logic, and then we can validate whether it's worth to go. And what can it gives us? Of course, efficiency and cost reduction, because as I mentioned before, we have this replicated objects and actions, so then we can easily create another process and another copy and paste. Of course, it's not so simple in complex solution, but basically that's the idea. Okay, so any question to that part? Okay, come on. What's your name?
Maciej.
Maciej, yeah?
Who creates those workflows? Who maintains them?
Mm-hmm.
You know, like the layout of a page might change. So, like, which kind of team within those companies is? Because it also requires some coding, right? So, who's the owner of those workflows?
Okay, from our perspective, we have RPA department. We have inside this RPA department, we have analytics small department, let's say, and developer department. So we are working with each other. So this analytic part is creating these documents and workflow and talking with business about the case. And developers are creating these workflows. If there is a need to create another object with another actions, developers creating it. About maintain, we have as well support team. So there is all the time support, because we can see whether when the robots are working or not. Robots are scheduled and so on. So it's working like that. Is it enough for a question? Okay, thank you. Any other questions? Yeah. What's your name?
Joanna. I have a question about, because I guess you are connecting different agents, different robots to different models, different LLMs?
We are not talking about this yet, because RPA, it's not AI technology itself. For now, this is just deterministic workflow, which we are creating. Yeah, but it will be in on the next slide how it works, how it will work, because it is the future, of course. So let's go to the innovation part, or maybe any other question. Last chance. Okay, if not, let's go to the innovation part. So we are entering a phase in RPA solutions, because to be honest, RPA is almost 30 years on the market. that we can change deterministic RPA workflows and becoming more dynamic and increasingly capable of making this decision in real time with AI agent solutions. So yeah, let's see what's the idea of that from my perspective. So RPA and AI agents. Where we can, how can we use it in RPA? Intelligent process discovery. So for now, we have analytic team, yeah, we have business department, which brings us an idea to create a business process. And in the future, I can see a possibility that separate agent, this LLM, which will be, will have specific knowledge about any department, any business department, can help to create a process itself during this document creation. So that's the first point. The second point is adaptive decision making. For now, as I mentioned before, there is deterministic path for our robots. So we are creating from start to the end, of course, in this loop. So in the future, I can see the possibility that there we will create this adaptive decision making inside our workflow. Then this AI solution, AI agent, let's say, solution will choose correct path during the processing of the specific business case. And the most important for me for now is optical character recognition. Of course, we have on the market plenty of solutions for OCR, but for now, from our perspective and from our experience, it doesn't work that good as we would like to. So for now, there is an opportunity that can work faster, better, with better accuracy from my perspective. Yeah, so that's the 3 point of how can we connect AI solution with RPA in the near future. So let's keep forward. And now, proof of concept, HR process. So we'll talk more about how we want to implement this, how we try and implement this. So the process is, let's say, simple, but there is sensitive data inside, because this process will look like to the HR department. There is a lot of documents which are not for now electronic, are just manually bring to the HR department. They are scanning it. Then when they scanned it, they need to prepare correct folder for the employee, move to the correct path in the network. So that takes them a lot of time when they have thousands of that documents. They need to know what type of document is that and so on. So in our process, the idea is that when they will scan the document, email will be sent to the robotic mailbox, and then a robot will take this email with attachment, can process it, can move to the correct folder, to the correct, and assign to the correct person. But we need to be in 100% sure that is correct person, because it's really sensitive data, and we can't afford that it will go to the wrong person. So that's OCR will not work as we want, because we tried this. So let's see how we will do this in the near future. So what robot will do? What will be the robot processing? First point, robot will prepare the folder with today's date, because robot will work every day. So robot will prepare for itself a folder with today attachments, with today emails, and so on. And then robot will gather this data from the email, all attachments, and prepare the queue with these emails and these attachments. And when we are talking about safety in that solution, of course, robot will not take the emails, which will be from the different email boxes that are not inside the mapping file of that robot. So if someone will send the mail to the robot. Robot will not do this because it's not the correct email. So that is robot processing from that point. And AI agent. Okay, that will be this part. Or maybe not. LLM endpoint. Okay, so that will not be AI agent, that will be LLM endpoint. You can ask me why, because AI agent can be autonomous, do it faster and so on. But there is plenty of rules that in our company, not only our company, huge organizations have. And as I mentioned before, that is really sensitive data. So why not AI agent which can work autonomously? First point, local LLM. We had workshops with our AI department, and they already have a local secured LLM, which is working across the company. And it was done, for example, 1 year ago, yes, and it's working, it's secured, it goes any path in the organization, so we just have it. So it's, of course, faster and safer for us because it's secure already. As I mentioned, it's a safe solution from our side. And faster delivery, it can show our organization that AI can work in hybrid with RPA, and then we can go to another step with, for example, autonomous agents. Faster delivery, as mentioned, and of course, RPA do the rest. So the idea is that we have endpoint to our LLM, which can have separate domain only for our RPA user, RPA robot, and then after robot will input this attachment to this LLM, then in the output we'll have information. If our LLM will not be sure in 100% whether that is correct person, correct type of document, then it will tell us, oh, I'm not sure, and that will be exception. That will not be success. The robot will not move this email, will not move this attachment, and that's the idea, because we can give our LLM context that if you are not sure, don't do this. Don't say the robot that it's correct in 100%. So yeah, we are coming back to robot processing. So we have these 3 points. Then we have our LLM endpoint solution. So we have input as attachment, output as information from our LLM. And fourth point, exception or not. Of course, as I mentioned in the beginning of our meeting, that RPA can be a success, can be exception, of course. And then if it's success, robot will do that attachment, will move this attachment to the correct folder, correct path, and so on. And if not, here we have exception. And what is our exception? Our exception is that what we call human in the loop, because every exception will be reported to the HR department at the end of the robot session, and then HR department can manually review this case as they did previously. So there will be work, but less work in the future with that solution. And if it's success or not, or exception, it will go to the next item by item in the loop. And when it will be ready, our robot just will end our business process. So that's the end of second part. Any question to that part?
Yes, what does exactly this LLM do? Like, why do you need it? Because I understand that lots of these things that you have there are like deterministic processes.
Mm-hmm.
So why do you have that here?
Yeah, because OCR didn't work correctly when we tried. That LM will do that work, for OCR. So this attachment will go via endpoint to LLM. LLM will use OCR itself and check what type of document is that and what kind of person is that. And as an output, there will be an information that that is this type document and this type of person. And if our LM will not be 100% sure, there will be information that is exception. I don't know, for example. Yeah.
And what kind of problems did you have with OCR? Because it's
accuracy, 60%.
only.
So that's the main point. So we believe that can be better. We'll see. We don't know yet because we haven't finished it yet. But we believe that can be there can be better accuracy. So, louder?
Do you use LLM for classifying itself, or do you use like a visual transformer for describing the picture, and based on the some keywords you classify the...
Thank you for that question. We are not on this path yet. We just will decide in the near future, but we don't know it. Someone questions? Okay. So if not, let's go to the last part. Validation. Of course, there was a lot of hype for AI since 2020, 2019, and so on. A lot of experiment, a lot of money disappear, a lot of billions of dollars, euros, zlotys. And now, from my perspective, it's time for huge organizations, small organizations, for everyone, that we need to check whether that it's valuable for us or not, because time for experiments probably just ending for now, and we need to bring a value for the organization when we are using AI. In our POC, we want to show the organization that is valuable when we hybrid with deterministic RPA solution, because it's a lot of safer, because we know from RPA side, from start till the end, what it will do. Of course, we have plenty of processes, more than 400 in RPA, business processes. So our organization knows that it's working from a lot of years. So when we will combine this, the next step can be, use maybe any autonomous solution with AI itself. So step by step from the scratch. And what about validation? More cost effectiveness. I read a little bit about this, and I have seen a PwC report where they said that in, for example, HR processes, when we want to integrate everything with autonomous AI agents, let's say, it can cost more or less 600,000 euros to prepare environment, to secure this, to do everything from the beginning. But of course, if someone is saying 600,000 euros, we know in IT that will be probably 1 million. So it's first point. So that deployment costs a lot for now when we want to start. The second point is, for now, when we want to deliver this value, this faster time to value, because we already have RPA department, we already have AI department, we have this LLM solution, we have a lot of solutions in RPA. So just try to combine this and let's see how it goes. And the third point is reduced risk investment. Nowadays, everyone is watching money, so we will reduce this risk to minimum from that point. So we can show, as I mentioned probably plenty of times during that presentation, that, okay, CEO, it's working, it's giving us money in time, so maybe go beyond this. Yeah, so from my perspective, hybrid RPA using AI but via API with endpoint is the smart choice for today. Because, of course, RPA solutions already have this autonomous AI agents itself. We can use it, we can try this, and so on. But maybe let's give the time for someone else to try this, to warm up this solution, and we go there when that will be sure that that's it, we can use it, that's safe, that's secured, and it can do autonomous things in systems in our company. Because, you know, if we have huge organization cannot afford that this AI agent will make mistake, because it can cost a lot, of course, yeah. So in that point, from my perspective, we can start from here. This is the smart choice for today, from my perspective. Give a shank to a robot. Yeah. So that's it from my side. The future of RPA. Any questions? We have questions. Okay. Thank you.
This cost effectiveness that you showed is coming from report, or this is something that you personally experienced?
That's from my personal experience, because we know that we can do it fast. Okay. And we, you know, any risk of investment is our time for now, because we have every environment for this, for that what we want to do.
Yeah, but have you measured this in some way, or just like your feeling that you're?
That's just my feeling.
So I have a question. For example, if you measure how your POC was doing, for example, per 100 documents, how many exceptions or something like that?
It's not working yet. It's just in the maintenance. So we will do this, and I will come back to you, and it will show you numbers. Next question.
Yeah, so this is the first thing I actually see this kind of technology RPA, so it's pretty interesting. And you said that it's useful for those kind of manual, repetitive tasks. So is there some possibility to have it record someone perform some actions, so then it could repeat that?
Yes, it's possible, of course, but from my perspective, better is to have documentation, because, you know, when we have business process from any business department, they can say something, and tomorrow that can change. Tomorrow I cannot work in that company. Someone will come and, oh, what's going on here? Yeah, you know, so we need a lot of documentation for that. And that's, from my perspective, smarter choice with that documentation, and do this manual block by block, let's say.
From my perspective, it might be very difficult to force people to document or force.
They're just coming to us.
Okay.
They're just coming to us. It's working from 7 years. We have 400 solutions. So, you know, you need to have good marketing in that. And then it works across the company. Because, to be honest, sooner or later, people don't want to do this, you know, monkey jobs. From my perspective.
At the beginning, there's a big enthusiasm when the communication is started, so the business has the opportunity to share with idea. Later on, when we have requirement, because we need to see the process, we need to report, and we start asking many questions, the enthusiasm is lower, yeah, because we ask a very detailed question, yes? What in case, how you act, what if doesn't work, what it works, what are the other options, because these are some kind of RPA limitation that we need to program all exceptions, yes? So we need to identify this exception. So this is some kind of challenge. And usually at this stage, the enthusiasm is getting lower, yeah? Because we are very interested in details. Yeah.
And answering for your question, of course, there is possibility to record all that steps that business doing, but for our perspective, it's always better to analyze how process works, because business cannot describe this process properly with
every exception. So it's better to hire an analyst to make this process robust.
Yeah, we know from experience that it's working, to be honest. Any other questions? Is it enough for your answer?
Like a matter of company culture as well.
Yeah, true.
So maybe when you implement the whole process, because you displayed the architecture, is it more granular when you really want to deep dive on implementation?
Of course, we can talk about this 2 days, but we don't have time today for that. And I thought that I will have 45 minutes. I have 2 hours, but damn it. I could done more, but for now, yeah, that's it. Any other questions? If not, I can share my QR code to the link in LinkedIn. So thank you for today, and see you later.
All right, so we'll have a tiny switch in speakers, and you will not listen about agents, but about something quite also as exciting. So Adrian will present how to really optimize the YOLO 26 from 43 FPS to run, so it could run on 903. Up to 900. So let's see. I'm not sure if it's possible. I don't know.
You don't trust me?
No. Need to prove it.
Okay, I will show. Yeah, it will be live. Yeah, I will show you everything. Do klikania, tak? Dobra.
Masz ten.
No. Tu widzisz?
Zobaczysz na ten content.
Okay, good. So you might think why I am here if there was supposed to be another competitive speaker, right? But this speaker is not here. So I decided to speak to you. And yeah, so in 20 minutes, I just prepared a deck and I just prepared a speech. No, I'm kidding. I am AI software evangelist at Intel, so I have many decks and many speeches. And that's why I already used one of them. And by the way, have you, any of you already seen this speech before? No? That's good. Perfect. So that's a perfect choice for today. So I would like today to prove that we can optimize UltraDX YOLO 26. And I hope that you know what YOLO 26 is. It's a model for object detection, right? And we will run from 43 frames per second running in PyTorch up to 904, 911, whatever, right? In OpenVINO and running on Intel. And I will do that in 45 minutes, and I will do it live in front of you. But first, the question, why? Why do we need to care about optimization? Why do we need to optimize? Well, there are a few things. First, it's improved performance and speed. So it's faster response time for crucial real-time applications, right? That's why it's good to have the results as soon as possible. Then, if we can run it faster, we can also reduce operational costs because we use less resources. We can serve more users at the same time, right? Then the next, energy efficiency, of course, related to the reduces costs and so on, because if we use less resources, we use less power and it's cheaper for us. Better user experience, of course, no one wants to wait 10 minutes for the AI results. Everyone would like to get the results as soon as possible. So that's why also optimization is super important. And the last thing, if we use less resources, we can also deploy in resource-constrained environments. So I hope already convinced you that optimization is super important because of all these things here. And then I would like to show you how. But to show you live, we were going to use this specific machine. So I have an Intel Core Ultra X7 358H CPU there with no discrete GPU card, right? It will be just this CPU. What is that CPU? This CPU was called Panther Lake before. It's a new Intel Core Ultra Series 3 released this January, so just a few months back. And it's especially good for Edge AI in very harsh environment as well, because it's good for extended temperature range from -40 to 100, 10 years silicon supply, functional safety, real-time support, and product tuned for reliability. So it's super good for Edge AI, and I'm going to use this specific CPU today to show you the performance benefits. And of course, in this specific CPU, there are 3 engines. The first one, there is CPU itself, right? This is very good for fast response, ideal for low latency AI applications, but there is also GPU, and there is no discrete GPU. This one is integrated GPU. So it's on the same chip, right? When you buy this CPU, the GPU is already there. You don't need to buy anything else. And there is one more thing, which is called NPU, Neural Processing Unit, and it's good for power efficiency. So if you need to run any AI workload in the background and not to drain battery so much, NPU is the right choice. And it looks like this, of course, the same chip, graphic style, different configurations, of course, depending on the specific SKU, but graphic style up to 12 XE cores. So the more the better, of course. On the system on chip tile, we have NPU plus some additional other components like display, media, image, and so on. And CPU tile up to 6 P cores. P cores mean performance core. So this is good for great performance. 8 E cores, efficiency core. So good for like less power, consuming less power, at the same time being a bit slower and weaker than P cores. So different configurations in this specific one. I don't remember exactly what is the P core to E core configuration and so on, but we can check it later if you are interested. Okay, so that's it. Let's do it. Let's go through the code. The default inference. For the default inference, we will use Ultralytics package. They deliver their models YOLO 26, YOLO 11, YOLO V8 in their package. So I should install it. Of course, I did that when I was there on the bench, so I'm not going to install it right now. But I can show you in a moment that I have that already. So let me find my terminal. Let's make it public. So first, ls CPU to prove that I am really running on this specific machine, X7358H, right? So this is the first thing. The second thing, of course, I am in the virtual environment already. So all the necessary packages are installed, including Ultralytics, of course, here, 8.4.50, and other things, of course, all the dependencies and so on. So this is the first step, of course, and we need to run the PyTorch inference first. This will be our baseline. So to do that, I will use the YOLO command, which comes with the Ultralytics package. And let's run it in front of you. Then I will use, of course, the data. It will be 128 random images from the Coco dataset. And model I'm going to use here is YOLO 26N, which means nano, the smallest one, right? Of course, we can use the bigger, but it's up to you. What would you like to use? Okay, so data, Coco 128, YAML, then model equals YOLO, not very equal, YOLO 26N, typo. Okay, running right now the inference, and after a few seconds, we can see that we have 23.5 milliseconds in average per one image, right? And of course, I would like today to talk about frames per second, right? Because it's easier just to understand 23 milliseconds is like, is it much or not? I don't know, right? But in frames per second, it's like easier for us to understand. At least I believe in that. So I start the calculator, and to calculate the number of frames per second, I need to divide 1 second, so 1000 milliseconds, by 1 inference time, and I'm getting 42, so about 43 frames per second. This is our baseline. We did that already in PyTorch because I didn't do anything else, right? And we used that specific CPU, and this is the results we got. But of course, we need to go up to 900, right, as I promised. So right now it's time for OpenVINO to enter the stage, and OpenVINO is an open source toolkit from Intel, which is focused on optimization and deployment, right? And it started as open visual inference and neural network optimization. That was the beginning. Right now, it supports any other kind of AI applications like transformers, audio processing, language models, GenAI, anything, right? But from the beginning, it was focused on computer vision. So for computer vision works the best, of course. So important thing here is it's open source, right? License under Apache 2.0, so you can use it if you would like, of course, for any kind of applications, right? Commercial included, of course, no problem. And if you have a model in any of these frameworks, today we are using PyTorch model, of course, YOLO 26 is trained in PyTorch, but you can still use TensorFlow, Keras, TensorFlow Lite, or NX, JAX, and so on and so on. And then you can convert to OpenVINO. That's the best way to do so, to achieve the best performance. And then you can deploy a variety of Intel hardware, from Atom, low-power devices, Core, Xeon server devices, Intel Core Ultra, which I have here exactly in this laptop in the machine I connected to. ARM devices as well, officially supported. GPU, integrated GPUs like Inter-R graphics, but also discrete GPU cards for clients and for servers, including Flex and Max series. NPU, I already mentioned that. It's also in my computer, and FPGA. And of course, it runs on any operating system, Windows, Linux, or Mac. So let's try it, right? So let's install OpenVINO. Of course, I did that before the session. But then let's convert the model from PyTorch to OpenVINO format. So to do so, we need to use another YOLO command, which is called YOLO export. And let's do it together. So where is my, here. YOLO export. And we would like to convert model YOLO 26N, and then format OpenVINO. Not easy to do that here if I cannot see what I'm typing. Okay, and after almost 2 seconds, the model is exported. So we can see that because the model has appeared here. So there is a new directory, YOLO 26N OpenVINO model. Inside, we have 3 files, YOLO 26N bin, YOLO 26M XML, and metadata. So in metadata, you have some information about classes used for training, license, image size for the input, and so on and so forth. XML file, architecture of the model, binary file for weights and biases. That's it. Then let's go back to our deck, and then let's run the inference. And to be equal with the previous situation when we used the CPU and we used the PyTorch and we used the Coco dataset, of course we use PyTorch. Right now we are going to use OpenVINO. But we are going to use exactly the same data, Coco 128, but we specifying the device we would like to use is Intel CPU. So it will be the CPU which I have here. So I'm going to reuse exactly the same thing. I'm just changing the model name, and there was also device called Intel CPU. I need to specify directly Intel CPU, otherwise it will be automatically selected for me, and I don't want that because, to be fair, I need to compare CPU to CPU. Okay, hitting enter, and after a few seconds, we can see that the performance right now is 19.9. So we gained something, not very much, but let's check that. So once again, 1000 divided by 19.9, and we are getting 50 frames per second. So we get 7 frames per second, just like a free lunch almost, right? Because we just converted one format to another, we used another runtime, and we didn't change anything in the model. The model is exactly the same as it was before. Good, but we can go better, of course. I promised you. So the next thing we need to talk about is quantization. It's a super important thing nowadays when you change the precision from floating point, which is quite compute intensive, to integer, right? So you do it by rounding similar numbers to the same number and then converting to integer. You remove outliers because you don't care about them. And that's the formula at the bottom, how you do that. Quite simple thing. And this quantization is super powerful technique because it can bring much better performance, and you will see that in a moment. So there are many different algorithms for quantization. In this case, we are going to use post-training quantization. It means that we train in the floating point precision, but after training, we can change the precision to int8. As you can see on the slide, model, trained model, still floating point 32. And after that, when we use the post-training quantization, which requires one more thing, which is called a representative dataset or calibration dataset, we can produce the quantized model. The calibration dataset is needed there because we need to capture all the values between layers. Of course, we know that the first layer, the images are from 0 to 255, right? The pixel value. But then in the middle of the network between layers, we don't know the numbers, right? You don't know if the range is from -1 to 1 or from -15 to 3 or whatever, right? That's why we need to put some calibration data set, which is going to feed the network and to capture all the values between. That's why we can find the right conversion parameters for the quantization. And what I like about post-training quantization, is that it works in many cases. These two videos, they show the same model. Of course, it's not YOLO. In this case, it's another model, which is called, this is open post model for post estimation, right? But the only thing between two of them, left and right, is that that one on the right-hand side was quantized. And when you look at the performance, it's like 40 in the floating point precision, and it's 80, more than 80 in int8. So we doubled the performance here. And you can, as you can see, the quality is, I would say, exactly the same. I cannot see any difference, right? We are able to detect all the people, the correct poses, and so on. So the performance is one benefit, but the second benefit is also file size. So if we change every weight from the 4 bytes, floating point 32, right, to 8 bits, 1 byte, we are decreasing the model size 4 times. And it's nothing crazy when we talk about 16 megabytes, but think about language models. 8 gigabytes versus 2, or even 70 gigabytes versus, let's say 80 gigabytes versus 20. It's easier to divide, right? But still, 20 gigabytes instead of 80 to use of your disk space, and the same to save your bandwidth when you download from internet. So this is super important thing. But the question is, what about YOLO? If the quantization affects the accuracy, in the case of YOLO, of course, we talk about mean average precision because it's an object detection model. And we measured that for YOLO V8, and it's, of course, older model. It's not YOLO 26, but still it's valid for newer models as well. And when we compared floating point 32 to int8, you can see that the difference is 0.003. I would say it's like negligible thing, right? You change almost nothing in the model quality. So in this case, this model specifically works well for post-training quantization. And how to do the quantization? Well, we use neural network compression framework. So you can use any of these formats. Of course, we do that in OpenVINO, but you can also do that in TensorFlow, PyTorch, or ONNX if your model is in those formats. So you can use different techniques here. We use, of course, post-training quantization, but also accuracy control quantization, weight only, quantization over training. All of these are available in NNCF, and it gives you some kind of compressed model. Of course, to visualize that, I just removed a few neurons and connections, right, to show that the model is like more sparse or something like that. But in case of post-training quantization, it doesn't look exactly like this. This is just a visualization. And let's use that. Let's use and let's see. So pip install nncf. I did that before. And right now we need to export the model again. Again, because we need to specify two more things. The first one is int8 equals true. We would like to quantize to int8, of course. The second thing, calibration data set I mentioned before. So data here equals cogot 128. It means that this specific data set will be used for the quantization as calibration data set. So let's do that. So once again, YOLO export format OpenVINO. Right now I'm adding two more parameters. Int8 equals true and data equals coco 128 YAML. Hitting enter, of course, it will be a bit longer. We need to use all the images to pass through the network, collect all the statistics. Is going to be done now, and after 12 seconds is done, right? So finally, we can see that here we have one more directory, YOLO26N int8, and inside this directory, we see that it's exactly the same, YOLO26N, XML, bin, metadata, and so on. But if we compare, the size, so right now it's 2.5 megabyte, and when we had floating point, it was 9.3, right? So the model is smaller. We quantized all the weights. Good. Now it's time to run the inference, of course. So let's use exactly the same command, almost exactly the same parameters. I'm just switching to a new model. So here, YOLO26N, int8, hitting enter. And as you remember, we had 50 frames per second, around 20 milliseconds, and right now we have 8.9, right? So it's much better. Let's calculate, of course, the frames per second, 1,000 divided by 8.9, and right now we have 112 frames per second. So we doubled, more than doubled that. And about the accuracy, right, or mean average precision. Yes, this is a very important question you didn't ask, but we can see it here. So that one was quantized, and this is the mean average precision, right? Or this is F1 score, I don't remember exactly. I think it's mean average precision, 0.459, and before quantization, it was 0.473. So yeah, it's a little bit bigger than 0.003, but still, I would say it's a very good result. Nothing crazy. Okay, good, but we can go even further. 100 is not 900. And right now, we need to switch to another tool to measure the performance. In Ultralytics package, we integrated a lot of different features from OpenVINO, but not all of them. So the next features I want to use, they are not available in Ultralytics package. However, they are available for the YOLO models. So if we just switch to a different performance measuring tool, we can use all of them. And this is called Benchmark App. Benchmark App is delivered with the OpenVINO package. So when you download OpenVINO via pip install OpenVINO, you get Benchmark App as well. And two important things from the Benchmark App. It reports latency and it reports throughput. So this is something what we are going to look at. And right now, I'm going to run exactly the same situation I did before with the Benchmark App. So we get 112 frames per second running with YOLO val. And right now, I would like to simulate the same situation with Benchmark App. So what I need to do is, of course, provide some parameters here, like YOLO, the path to the model. I'm going to use, of course, int8 model because we stick to that. Now, then I provide -t, means 10 seconds. So I don't want you to wait more for the results. So we are going to measure for 10 seconds. API, which is synchronous, CPU, which is the device we select now, and then hint, which is latency. I will explain that in a moment. Hitting enter, and we are running exactly the same situation we had before, but let's look at the current results. So we had 112, and right now we have 130, a bit more. And why? And we did the investigation because it was super weird that we have a bit different performance. But we realized that Ultralytics and us, we measure inference in a different way, right? We measure in benchmark app, we measure really inference only, just inference, no pre-processing, no post-processing, no even copying any memory, nothing, right? Just inference. However, Ultralytics, they do that in different ways. So if you need to convert some data in the memory, they also measure that time. That's why we are a bit better, because we measure just less stages of this process, right? The real stage, the inference. And of course, we can do similar thing for the GPU and NPU, and we can see how fast we are. So far, we just used CPU, right? So we can also see the GPU. And once again, this is the integrated GPU, no discrete cards here. And let's see the performance. So 130 for CPU, for GPU, which should be better. 660 already, just using GPU, right? And NPU, will be, let's see how much. 138. But we can go even better. Let's go back to the slides. The next thing, I told you that we used hint latency. What it means? Well, latency means that you would like to get the results as soon as possible. It's obvious thing, everyone wants, right? But it means that it's like a streaming application. You are getting one frame, then you are waiting for the next frame, because it's streaming, right? You don't know the future frames. That's a latency case, good for latency case. And in that case, you select one device, because we discovered that, from our experience, using one device and one processing unit from that device is the best for latency. So for latency, even if you have many different devices, even if you have many cores in the CPU, you will use just one of them, because for the latency, this is the best choice. So this is latency, right? One queue for the request, one processing units used to get in the results as soon as possible. On the other hand, we have throughput mode. And in the throughput mode, you select still one device like CPU or GPU or NPU, but you use all the processing units. So if there are more cores than one, you will use all of them in parallel. That sounds like a better performance, right? Better throughput, because you run something in the parallel. Yep, it will be like that, of course. And there is also auto batching feature, which means that you are batching some inputs together, right? So when the first input comes, it waits for the second, for the third, for the fourth, and when the batch is full, it runs inference on all of them at once. And it's similar for the second batch, it's similar for the third batch, and so on. So it works like that, right? It's done automatically. If you select the throughput mode, you change the hint, like from latency to throughput, it works like that automatically. Good. So let's do it in the throughput mode. So let's go back to the CPU. I would like to continue with the CPU, and let's change the hint to the throughput. I think I did it correctly. So 130 frames per second in the latency mode, but when we use all the cores together, we will get 39. It's even worse, right? It's 4 times less. So what happened here? Well, there is one important thing. The synchronous API for the heavily parallelization is not the right thing. We need to switch the asynchronous API. Because in synchronous API, you transfer data, you run the inference, and when it's ready, you transfer the second data, and you run the inference. But meanwhile, you have an idle time, right? That the device does nothing. And when we change to the asynchronous API, you transfer the data, you start the first inference, but when you run the inference, you transfer the second data. So you can start the second inference immediately after the previous one. So the second result, of course, is faster, is quicker available. And asynchronous mode is the fix here. So if you switch from the synchronous API to asynchronous API and use the throughput mode, so 130 in latency mode, 40 in synchronous throughput, and asynchronous throughput is 270, right? So now it's better. Now it's good, right? And there is one more thing, because we still don't get 900, which I promised. Well, there is one more performance hint, cumulative throughput. So throughput means one device, all processing units. Cumulative throughput means all devices, all processing units. So we can use CPU, GPU, and NPU all together running the same. And I'm going to do that. It's called multi-device execution. We are going to use all the devices, and we are using this cumulative throughput mode. So cumulative first, and device multi GPU, NPU, CPU, all of them. And yeah, it started. You can see that we have 3 devices running here in this line, and 917, right? So we finally achieved 917. Of course, it varies. When I ran it before, it was 903. Sometimes it's 920 something or so. But this is something which is quite good, right? Because right now, if we compare that to the first baseline in PyTorch using just CPU, which was 43, we are 21 times faster right now. Means 21 times more throughput. And there is also one more thing. I can also run in the throughput mode CPU, GPU, and NPU independently. So CPU was 270, if I remember correctly. GPU in the throughput mode will be 425, and NPU will be let's see. So 270 plus 425 plus 112, 797. So this is a bit unexpected because it should be more than 900. That's what my was expectation. Usually it is. I don't know why it's right now it's slower. It should be more than 1,000. This is my experience. And I wanted to explain you why 1,000 when we run separately and why 900 when we run all together at once. Of course, which is not true today. But usually it should be true. Because when you run multi-device execution, one of the devices, usually CPU, must be the manager of the inference, right? It must select where to go now, GPU or NPU or whatever, right? So the overhead for the management is about 100. This is the usual thing. Today, we didn't prove that, of course, but usually you should know that when running multi-device execution means that one of the device must work as a manager. And not all the, like power for the management, but some of the performance will be sacrificed for that. And if you would like to try at home, we have also 2 demos, 2 open source demos. One of them, this is me, of course, in the office. You can count people standing in front of the webcam or something. It's running YOLO 26, it's running YOLO 11, it's running YOLO V8. So if you would like to try on your computer, this is, of course, latency mode. So this is not a throughput mode. You are not going to achieve 900 or something, right? It will be a bit slower because it's a different type of application. So this is one thing. Of course, the second thing, if you would like to test it more for the manufacturing use case or something like that, you can try to detect objects running on conveyor belt, for example, or like you can just move them in front of the webcam and they will be tracked, counted, and so on. And they run also YOLO models. This one is YOLO world. YOLO world means that there is open vocabulary. You don't have to select one of the categories from the Coco dataset. You can type the category you would like to detect. Hazelnuts, they are not available in Coco dataset, but I typed, I would like to detect hazelnuts today. And because there is open vocabulary, so there is a part of the language model as well, it understands that. So this is also a super cool thing. But of course, try it yourself. This is the QR code which goes to the Ultralytics documentation, which is OpenVINO and Intel integration described there. So you can see the benchmarks there as well, officially done by Ultralytics. You can see how easy, of course, I presented today, how easy it is to do it in the command line. There is also Python API showing how to do that in Python. And yeah, I think that's all from my side. I can see that people still are taking photos, so I'm not going to switch this slide for a moment. And I hope that I convince you that optimization is super important, right? Because you can achieve much better performance when you just use some tricks like quantization, using this asynchronous API, running on multi-device in parallel, and so on and so forth. So that's all from my side. If you have any questions, I am happy to answer them now.
This calibration data that you mentioned on post-quantization process,
Yeah.
How do you go about this? Like,
Where do you find it?
no, how do you define it? Like, because you have the defined data set.
Yeah.
How do you go? It's like 30% for training, 10%
Okay.
for quantization.
Okay. So if you train your model, usually using like most of the data go for the training, some of the for validation, some for testing, right? So I never use testing for the quantization, right? Because testing is just for testing. For quantization, as calibration data set, validation data set will be okay, right? You can also use training data set for that, not a problem. For the quantization, we just require around 300. This is the minimum, 300 images. If you provide that, 300 images, 300 sentences, whatever, 300 audio samples. But 300, when you have thousands of them, it's nothing, right? So 300 is absolutely enough to capture the most of the data, right? Because they come from the different, they are different, right? So some of them are, like giving the numbers on the negative side, some of them giving on the positive side, but they do the average when you have 300, so it's enough.
Yeah, so is there some, some good practices there? Like you mentioned 300 minimum, but is it like 10% of some training data, for example, would be?
I wouldn't say in percents. I would say like 300, this is the minimum. Of course, the more, the better, right? Because you are more accurate. But if you cannot even afford that, you saw we used 128 for the quantization. It was absolutely enough. We even proved in the past that 8 images were enough for the quantization. Of course, your mean average precision drop will be bigger, right? Because if you don't capture exact data, you don't have enough data, then the quality of the quantized model won't be as good as in case of more data. But let's say 300 is like good sweet spot.
That would affect, like, could affect on testing, right? Like,
yeah.
Data could be like outside of the samples that were used.
If you can afford 1,000 because you have, it will be like better accuracy, something like that, right? You will lose less of the accuracy because you have more accurate situation, more data.
So it's rather about the data set distribution than the number of images?
Yes, this is it. Yes, exactly. If you can capture with 10 images just a good distribution of the entire data set, it's okay, it's enough. And because we don't know that, and we usually use randomness for that, right? Random 100, random 300 images, and probably you are good. Any other questions?
Maybe one
like comment addition. I've been working on quantization just with 8-bit floating points. Yeah. And this is a bit similar. This selecting the range where the values are is just also the was included by just adding bias to the exponent. So it's similar and it's really works good. Yeah. So but these 8 bits for integers with this scaling of these floating points, it's a really nice thing, and generally we lose very little of quite like you showed this. And about this, what you showed, this is very nice, just showing how to parallelize the processing and getting the throughput. But it's mainly for batch processing, because if you need streaming,
it's latency. Yes.
And the latency is very important, and the order of processing. Yeah.
That's true.
Stream a lot of streams at once, then you can try, but delay will be the problem.
And the throughput mode is good when you have a video already recorded. So you have all the frames. You can schedule all of them in parallel, right? In the webcam stream or something, you don't know future frames, so you cannot do that. But when you have the video recorded, you can, right? And there are some applications when you would like to process entire video, which was already done in the past.
Preparing data for training.
Yeah, for example, yes. And you mentioned also floating point quantization, because int8 quantization is not the only one which is existing now. Floating point 16, this was the first like kind of quantization, let's say. bfloat 16, which is used in Intel CPUs, server CPUs. bfloat means brain float. It's like the same as floating point 32, but the mantissa is shorter, just shorter, right? There is also floating point 8, a new thing. It will be available in hardware in the next generation of Intel CPUs. Right now, it's not supported. So if you have floating point 8, it will be converted to floating point 16, for example, to run on the CPU. But in the future, it will be natively supported in the CPU, right? There is quantization to int4. It works well for the language models, for example. So it's even less than int8, right? Quantization to bit level on something. They are crazy things, but there are many different types of quantization. Yep, thanks.
We have some time for networking, so keep yourself busy networking and in the kitchen if you'd like. And also, thank you for joining, and see you next month.